I would like to also, before we go into details about this specific set of topics, just to mention the word entity separately. So we talk about entities. Entity equals, something like thing, which could be an object of some kind, and it has all kinds of properties and operations that can be done internally or externally with this object, and so forth, right? But entity also in software has very specific, the term itself is used also very specifically in most contexts as a persistent entity. And persistent entity is equal to basically a record, and the record includes data fields. Okay, and so this may look like a record with certain data fields, like name, phone, date of birth, social security number, and so forth, something like that. So the record really holds the set of data fields which are directly related to each other, so they're just making sense to be used together. And most likely a record also means persistence, so that it is probably stored somewhere in some kind of a file system or a database system somewhere on disk or other device that can retain digital information, right? So it can be retained or managed. So just like there's this dual sort of like usage of the entity term. I use it as something which is a real thing when we talk about our application, or persistent entity, which just simply is a record. So that I would like to tell you that this is the case. And when I think about system design, I always kind of fail over to this area when I talk about entities during the design. For me, entity is equivalent to a persistent entity. To me, in my head, when I say entity, when I'm doing my design, it's an equivalent of a database record. Some kind of system that can retain the information, persist the information, and that's what this is. So you will see this distinction and importance of an entity pretty soon when we begin to explore actual examples, right? But at this level right now, it's almost like we can think about anything as an entity. But sometimes designing object-oriented system can be done simply by asking, say, an expert user a set of questions basically about the records. What records do you store? What records do you retain in your business, right? So for instance, if you're running a bank, you have bank accounts, you have customers, you have organizations which own these accounts. What kind of accounts do you use? And you can find all of this information somewhere in a database that they have, right? There's a database which has areas dedicated specifically to customers, accounts, and so forth. And inside these database tables or whatever database is used, there could be these records identified. And I would say that this is an incredibly useful source of information specific to our process of solving the problem. It's very important. So sometimes it's very useful to approach your own investigation about the problem by simply finding out what is retained in the database. So in that world, persistent entity is basically your discovery of things. But entities which could be viewed as records could quickly lead us to an imagination of a real object, because the software first has to locate the record, load that record into memory, perhaps populate these fields inside a certain object, and then have this object used in the rest of the system at runtime. When the system executes, this information has to make its way into computer memory so that we can do computations, analysis, searches, executing different kind of algorithms with this information. Right, so that's just my kind of little discourse about the term entity, so that you're aware of these different perspectives regarding the entity. So different meanings sometimes, right? But we say here that encapsulation means concealing characteristics of an entity. Concealing means simply hiding, both grouping, like organizing together, and also concealing, essentially preserving or hiding certain characteristics and making them internal to that entity, as opposed to just everything being exposed to all parts of the system. Right. So the entities can be perceived through specification, like description. Like, for instance, you go to a store and read specification for a washer machine, right? That specification really doesn't tell you how it's made. Sometimes by reading the specification, you can, without seeing the actual device, you don't even know what type of device it is. Is this like a top load or side loader or something else, right? You just read the specification. It may not be telling you a lot. It could be telling you what the capacity is, what the length of the cycle is, or something like that. But it doesn't really give you an instant picture of the device, even if it's certain types that could exist, right? But if you look at the implementation, and how do you look at the implementation? Well, you either go through some kind of internal documentation that presents you everything that this is made of, or some kind of manual, a technical manual, or you explore it on your own, because maybe you have an instance of that device that you can actually explore, right? So there are specifications. There could be, one specification, but multiple implementations, right? You can have a specification, but you can have different types of implementation. You can describe what the washer machine should do and how it's supposed to behave in the specification, but it could be done different ways and implemented by multiple devices. So this is kind of interesting aspect here, that specification is much more formal and much more abstract than the actual implementation. Right? But both sides kind of lead us to understand how things should be grouped together, how things should be organized, and so forth. Also interesting note that the encapsulation, this grouping, this organization in a programming language, programming environment, and perhaps starting even with at the time of the design, it should be enforced by that environment. We just simply would like to say that we want to use a programming language and programming environment which allows us to create classes of objects which naturally encapsulate the data inside of these objects, which provide both private and public parts and so forth. So that would be very desirable, and this is the direction in which we are moving. So, generally speaking, encapsulation is the term which is used very early. So again, I would like to just highlight what I think about this term encapsulation. First of all, in my mind, this is organizing things under one roof, right? Basically putting things together into one box with well-defined boundaries, number one. Number two, ability to hide things internally, and ability to expose, make public only specific parts, and call it and make it part of the specification. Everything else becomes implementation. And even furthermore, there will be different levels where we use inheritance. There will be things that could be derived different ways from one another, and this encapsulation set of ideas will just keep piling up. And I think it's time for us to take a break and move to a different room, so we'll just take a break now.